Every day, over 40,000 students and staff make their way to the University of Birmingham. With this many people in one place, it is important for there to be safety regulations when stuff goes wrong. This year saw the completion of the brand new 5-floor main library on campus. At any time there can be more than 2,700 students and staff within the library. The library is made up of a ground floor with 4 increasingly smaller floors above. They are connected by a main staircase in the centre and 3 more staircases to the north and south of the building. The fire exits are all on the ground floor, and these are in the north, west, south walls as well as the main exit. For our first model, we took a simple 60 by 60 metre square with exits at the centre points of each wall. We then split the box into 4. The furthest person from each exit is at the centre point of the room, which is 30 metres from the exit. The average walking speed is around 1.4 metres per second, so it will take 30 divided by 1.4, which is 22 seconds for the last person to leave, so the evacuation time is 22 seconds. For our first model, the assumptions we use is that everyone walks at the same speed, everyone goes to their nearest exit, and that their time to start walking to the exit is 0, and that the box is open plan with no objects obstructing the evacuation paths. For our second model, we used 5 floors, all 60 metres by 60 metres again. This time we incorporated all 4 of the staircases, although we only need to worry about the centre staircase as this one is the furthest from an exit. We placed an equal number of people on every single floor of the library. From our testing, we found it took 15 seconds to move from floor 4 to floor 3, 22 seconds to move from 3 to 2 and from 2 to 1, 28 seconds to move from 1 to the ground floor, and 22 seconds to move from the ground floor to the nearest exit. Note that these times include walking from the bottom of the staircase to the top of the next. Also note that we do not include the ground floor evacuation time in the following calculation. This is because it will have cleared in the time it takes for the people from the floor above to get down to it. We also found from our testing that 3 people can fit on the stairs side by side, and that groups can walk 1 second apart. Now we have the time it takes for the first group of 3 to descend the staircase, plus the number of people left on the floor, divided by 3 because 3 people may pass at once, then divided by 4 for 4 staircases on the floor, all multiplied by the amount of times that floor needs to be cleared. For example, the third floor has to be cleared twice. The people that are currently on the floor need to exit before the people from the floor above can then exit. So the 4th floor has to be cleared once, the 3rd twice, the 2nd 3 times, and the 1st floor needs to be cleared 4 times. Looking at the evacuation times for each floor, we can clearly see that floor 1 takes the longest. If we take this time and then add another 22 seconds for the last person who leaves the floor 1 to get to the exit on the ground floor, we have our final result. For Model 2, we keep the same assumptions as for Model 1, but we also add that everyone must go down in their 3s and that everyone keeps the 1 second separation. For Model 3, we built on our work from Model 2, with the main focus of improving the accuracy of our solution. To do this, we took the exact number of people on each floor. The values for each floor are as shown. Using similar calculations that we used in Model 2, we take the time it takes to descend the staircase from that floor, or for the ground floor case, the time it takes to get from the staircase to the furthest emergency exit. We then add the amount of people on that floor minus 3 divided by 3 for 3 people on each step, divided by 4 for 4 staircases, or in the case of the ground floor, for 4 emergency exits. Now, unlike in Model 2, we then have to add the amount of people on the above floors, all over 12. This is to account for the different times it will take to evacuate a different amount of people on each floor. From our results, we can conclude that it would take 250 seconds to evacuate everyone from all 5 floors of the library. For our third model, we used the same assumptions as for our second model. Two possible extensions to our model would be to consider the actual shape of the library and to consider more closely overlapping times between the evacuation of each floor.